Hi, I'm Philip, and in this video I will talk about the accuracy of the Revopoint POP4 and how I measured it. So for the scan setup, because I want to test the accuracy, I placed the micrometer on a turntable and put marker geometries around the turntable, so I can even scan the micrometer from more shallow angles. The turntable is also not rotated while scanning, simply to prevent wobble. For context, I know that the micrometer isn't the best approach. Currently, a ball plate is already on the way, and when it arrives, I redo the test, also for the other scanners I did with the micrometer. The micrometer simply was like the best tool I had till now. And I wanted to get the initial accuracy testing out before the Kickstarter for the POP4 ends, so you can see the results and decide what to do with them. But spoiler, they are very good, but we will see them later. Now about the scan spray usage, you may already know it. You can also just skip the results or see the post on Reddit about the topic. So the micrometer itself, it is calibrated freshly to 125.00 millimeters plus minus 0.01 millimeters, but the anvil and spindle are polished to a mirror finish, so they're like carbide tips. Therefore, I need scan spray on both of them, so it can be captured better with laser scanning. And I used a thin coat of Esa Blue. The thickness per manufacturer's spec is roughly 8 to 50 micrometers. So I used 8 for the calculation because it's a thin coat. Therefore, the nominal will be 124.9484 millimeters because we have two coats on anvil and spindle. Now to the scan settings I used for scanning. In the laser mode, I did 0.2 millimeters target resolution and then simply scanned until the data quality indicator showed me that I'm finished with scanning, and then I fused and meshed at high quality with a target resolution of 0.2 millimeters again, and I did 6 repetitions. I didn't yet test the full HD mode simply because the sharp edges and small area of the contact faces of Micrometer are simply not suitable for IR mode scanning. For this, the ball plate will be the better subject for testing. So yeah, it's on the way. Now for the scan results. On the left, you see all 6 repetitions with the POP4, and on the right, we have a closer look at one of them. So especially around the anvil spindle, you can see it's quite smooth because that's the areas where I applied the scan spray. Now to the measurement process itself. So I import STLs into the STL files into QuickSurface. Then I extract primitive planes on the anvil and the spindle. For the first one, I used the automatic selection QuickSurface, and the second one is also automatic but constrained to be parallel to the first one. And then measure the distance between the planes. Now about the stated accuracy of the POP4. So here you can see the volumetric accuracy to be 0.03 millimeters plus 0.05 millimeters per meter scanned. So for the 125 millimeters of the micrometer, we come to around 0.036 millimeters of accuracy. Now about the results for the laser mode. The mean value, sorry, I see that the animation is a bit crooked, but it will work. So the mean value, well, keep in mind the nominal is 124.984 millimeters. Here you can see it. The mean value is 124.993. This leads to a delta mean of being 0.009 millimeters error, and with a standard deviation of 0.01. And since the spec is 0.036 millimeters at the 125 millimeters, we are well within spec. So this is actually quite an excellent result, as we will see in the next slide. Here, single measurements. Here in the next slide, we have in the dark bluish color in the middle, the straight line, the nominal. And here in this very dark green, we have the POP4. So it's quite close group, and best way is to just look at all the values, and you can see the delta mean and standard deviation is very excellent of the POP4. So also the Metro Pro also had the track it had quite good results, especially the track it in the marker mode had I think it were the best results I captured until now. The tracking mode wasn't as accurate, but still very impressive. I hope this could help you a bit and help decide. But have a nice evening. It's half past 3 in the night here in Germany, but I wanted to get it finished.